Have you ever just looked at a massive valley or maybe a super sharp mountain peak and wondered what on earth could have the power to create something like that? Well, it turns out some of our planet's most incredible landscapes weren't made in a flash, but by this slow, grinding, and unbelievably powerful force.
So let's just ask the big question right up front. How do you do it? How do you take solid rock and sculpt it into the kinds of peaks we see in, say, the Alps or the Rockies?
The answer is kind of mind-blowing. The artist behind these masterpieces is a glacier, a massive moving river of ice that acts like a planetary-scale sculptor. Yeah, it's not just frozen water, it's this dynamic, world-shaping force. Okay, so to really understand how a glacier can do all this, we first need to get what it is. And, like a lot of really big things, it all starts with something very, very small. It all begins with simple snowflakes. In places where more snow falls than melts, it just starts to build up, year after year after year. So as all that snow piles up, the sheer weight of it is immense. It presses down on the delicate crystals below, squeezing out all the air and forging it into this dense, solid glacial ice. And eventually, this whole mass gets so heavy that gravity just takes over, and it starts to move. And right there, our sculptor is born. And of course, every sculptor needs their tools. Glaciers are, well, they're brutally effective. First, you've got sapping, which weakens rock by freezing and thawing water in its cracks. Then there's plucking, where the glacier literally rips out huge chunks of rock that have frozen to its base. And finally, there's abrasion. It uses those same plucked rocks to just grind away at the bedrock like cosmic sandpaper. Now, let's head up into the highlands to see how these tools create some of the most spectacular features you'll ever see. This is where the glacier's work is at its most dramatic. This is often where a mountain glacier is born. It's called a corrie, or a cirque, and it's this incredible arm-shaped hollow. The ice inside kind of moves in this rotational slump, grinding out the bottom and plucking rock from the back wall, carving this amazing shape right into the mountainside. Okay, so what happens when you get two of these corries forming back-to-back on a mountain? Well, the glaciers eat away at the wall between them from both sides, until all that's left is this razor-sharp, knife-edge ridge called an arete. And you can take it one step further. When you get three or more corries gnawing away at the same mountain, they create an iconic, sharp-pointed, pyramidal peak. The Matterhorn in the Alps? Yep, that's the perfect example of this incredible process. As the glacier flows down from the mountains, it usually follows the path of an old river valley. But here's the difference. A river carves a V shape. A glacier is more like a massive bulldozer. It just scours the entire valley floor and its sides, completely transforming it into this distinctive, wide, flat-bottomed U shape. But wait, what about the smaller valleys that used to feed into that main one? Well, the main glacier is so much bigger and more powerful that it carves its valley way, way deeper. So after all the ice melts, these smaller tributary valleys are left just hanging high on the side of the main valley. It often creates the most spectacular waterfalls you've ever seen. So, after carving up the mountains, the glacier's journey keeps going. It spreads out onto the flatter, open lowlands, but believe me, its power to shape the land is far from over. Out here, the glacier runs into these stubborn knobs of rock. The result is a feature with a fantastic name, a roche-montagneuse. And what's so cool about it is that it acts like a geological signpost, telling us exactly which direction the ice was moving. Here's how you read this signpost. As the glacier flows over the rock, the side it hits first, the upstream side, gets smooth and polished by abrasion. But on the other side, the downstream side, meltwater refreezes in the cracks, letting the glacier just pluck away chunks of rock. This leaves a rough, jagged face, smooth on one side, rough on the other. This is a similar idea, but just on a much bigger scale. A crag is a big chunk of hard, resistant rock, maybe volcanic, that stands in the glacier's path. It basically acts as a shield, protecting all the softer rock behind it from being eroded. That protected rock forms a long, gently sloping tail. Edinburgh Castle, by the way, is famously built on one of these. So eventually, the climate warms up and the glacier's long journey comes to an end. But as it melts and retreats, it leaves behind one last powerful legacy, written in all the rocks and soil it carried for miles and miles. This is what we call the deposition phase. I want you to think of the glacier as a giant conveyor belt. All the rock and debris it scraped up from the land is called moraine. When the ice melts, that conveyor belt just shuts down, and all the material it was carrying is just dropped right where it is, forming these huge ridges and blankets of stuff we call boulder clay. Now, this process leads to some truly strange sights. I mean, imagine you're walking through a completely flat field, and there, in the middle of nowhere, is a single massive boulder that looks totally different from all the local rock. You'd have to wonder, how on earth did that get here? Well, the answer is, it's an erratic. The glacier acted like a giant transport truck. It picked this boulder, sometimes the size of a house, up from maybe hundreds of miles away, carried it along for the ride, and then just unceremoniously dropped it as the ice melted. It left behind a geological stranger in a strange land. Geologists have a fantastic and kind of funny description for the next feature we're going to see. They say the landscape looks like a basket of eggs. And what they're talking about are drumlins. These are these long, whale-backed hills made of moraine that was dumped and then streamlined by the moving ice. They almost always show up in big groups, or swarms, and they're all lined up in the same direction, showing the final flow path of that ice sheet. And finally, as the very last of the ice melts away, you get these huge torrents of meltwater. This water sorts through all the leftover debris, creating eskers, which are basically the fossilized beds of streams that flowed under the ice, and these vast outwash plains of sand and gravel that fan out from the glacier's final resting place. So, from the highest mountain peaks to the lowest plains, glaciers have been the master sculptors of our world for thousands of years. They created the very landscapes that we see today. The real question for our time is, as the world